Welcome everyone to this lecture on the SELECT statement. SELECT is the most common statement used in SQL, and it fundamentally allows us to retrieve information from a table that exists within a database. Later on, we're going to be learning about how to combine the SELECT statement with other statements to perform more complex queries. So what's the actual example syntax for a SELECT statement? Well, after opening up the query editor, what we're going to write for our most basic SELECT statement is SELECT column name from table name. And you'll notice that in general, we capitalize the SQL keywords. This actually isn't 100% necessary. SQL will still run even if you don't capitalize these, but it makes it much easier to read what are the fundamental SQL syntax statements versus what are the column names or table names that you're yourself editing, depending on what you actually want. So the most basic syntax here is we choose a column name from a table. So let's see how this actually works within PostgreSQL. So we already know that we have a database, and then we right-click on that database and we open up that query editor. In our case, it will be the example DVD rental database. And so the way PostgreSQL operates is inside of this database, you're going to have some number of tables. Here we have an example of 3 tables. And recall then each of these tables is essentially like a spreadsheet. We have columns and then rows of data. And here I've just made up some data. So each of these tables has columns 1, 2, and 3, so C1, C2, C3, and then rows of made up information. When we actually say select column name from table name, PostgreSQL essentially reads this a little bit backwards. It first has to decide what table you're referencing. It already knows what database you're referencing because that's how you open the query editor on that database. So it takes a look at what table name you're looking at, and then it's going to take a look at the corresponding column name. So, for example, we could say select C1 from table 1, and it would look something like this. It's actually grabbing column 1, and it'll return back that entire column, and X, Y, and Z. If we want to select multiple columns from a table, we can say column 1, comma, column 2, etc. You just separate out the column names by a comma. And keep in mind, these don't need to be in order. So if you only wanted column 1 and column 3, you would just say select the names of your columns separated by commas and then from the table you want them in. If you actually want all the columns from a table, you can use an asterisk symbol in order to request all the columns from a table, essentially just asking for the entire table back. So you'll say select an asterisk and then from table. In general, it's not good practice to use an asterisk unless you actually want every single thing in that table. And what's going to happen here is if you use the asterisk in the select statement, it's going to automatically query everything, which increases traffic between the database server and the application, which can slow down the retrieval of results. So you should really only be using that syntax if you actually want the entire table back with all the columns in it. If you only need certain columns, do your best to only query for those columns. Let's go ahead and walk through some examples in our DVD rental database to get some practice with these basic select statements. I'm going to open up pgadmin. Alright, so I've opened up pgadmin. I'm going to click down on servers. Note that I have different versions of PostgreSQL installed on this computer. Go ahead and choose the one that you installed for your computer. I'll go ahead and choose PostgreSQL 12 since that's what we'll restore DVD rental on. I've now connected to that server under PostgreSQL 12, and now I want to query the particular database inside that server. So that's going to be DVD rental. I right click, and then I'm going to open up the query tool. I take a look at the query tool and I have the query editor as well as the data output. So let's practice our very first query to this database. So if you're ever curious of what tables are actually available to you in your database, what you can do is underneath DVD rental, you can open up schemas. You'll see there's a public schema, keep going down, and you'll see there's tables here. And you can expand on tables, and I'll show you the various tables available to you inside of this database. And you can check out the resources for this lecture or the previous lectures. We actually have a mapping of those tables and the relationships between them. We'll talk a lot more about joining tables together and also programmatically asking a database what tables are within it. But right now, we'll just do this through the pgadmin graphical interface. So I can see there's 15 tables here. And if we click on one of these tables, we can later on see what columns are available, etc. So let's go ahead and start by asking for an entire table back, or all the columns in a table. I say select and then I type in an asterisk there, from, and then we'll say actor, semicolon. And then I'll go ahead and run this. And if you're on Windows, you can choose F5 to quickly run that. And you'll notice that it has the data output. I'm going to kind of move this over so we can see this. And we can see here it has the actor ID, the first name, the last name, and then the last update. And we can scroll down here and see the various results. So again, this returns back all the columns. If I only want a single column, let's say I only wanted the first name, then I just look at the column name, which is first underscore name, say first underscore name, and then I'll go ahead and run that. And now I only get back the first name. If I want the first and last name, I would take a look at those column names, which I can always refer to over here on the side. Last name's available there, and then run that. Okay, so I can see first name and last name. And keep in mind, they actually don't need to be in any sort of order. If I wanted the last name to show up first, I could say last name, comma, first name, run that, and it would show me in the order I requested. The last name column showing up first, and then the first name. Everything's linked here by what row. So we can see Penelope Guinness, Nick Wahlberg, etc. Now, a few more points I want to show you is that you notice that I capitalized the SQL syntax keywords, but even if these were all lowercase, select, and then I put from in all lowercase, and I run this, it will actually still work. It's the same thing. However, it's much easier to read, and it's just standardized notation if we just do this in all caps, and then I can quickly realize if I'm coming back to this, that select and from are the keywords. And notice pgadmin also highlights them for us. You'll also notice that I have a semicolon here. The semicolon is to denote the end of a query, but if you delete that semicolon and still run this, you'll notice it works just fine. So things like capitalizing those SQL keywords, as well as adding in that semicolon, really helps as far as readability is concerned, especially if you're going to be sharing these SQL queries with someone else. It can read very clearly where this actual query is meant to end, as well as what commands you're actually using. You can use the scratch pad here if you want to kind of play around with things later on as our SQL queries get more complex. You may want to work a little bit on the scratch pad. And I'm going to zoom out just so we can see this clearly. There is a query history that you can click here, and you can see the various query histories. And then you can always copy them, or you can copy them directly to the query editor. So for example, if we come back here, maybe to select first name from actor, I could say copy to query editor, and it jumps back to the query editor, and I can see select first name from actor is already there for me. All right. And then if I wanted to, I could run this and edit it in any way I want. So I can just double click here and start editing for another table. Maybe I want all the columns from another table. Let's say select everything from city, semicolon, hit F5, which is essentially a refresh or running this. And we can see here city ID, city, country ID, last update. Okay, so those are the very basics of the select statements. Coming up next, we're going to have just a few challenges to make sure you understood all this. I'll see you at the next lecture. Welcome back, everyone, to this lecture on select distinct. Sometimes a table contains a column that has duplicate values, and you may find yourself in a situation where you only want to list the unique or distinct values in that column. The distinct keyword can be used to return only the distinct values in a column. The distinct keyword operates on a column, so that means the syntax looks like this. We say select, and then distinct right in front of whatever column we're interested in grabbing the unique or distinct values from, and then we'll specify what table this column is in. Sometimes, to clarify which column distinct is being applied to, you could also add in parentheses for clarity. So note that distinct on a column works with or without parentheses. This is what it would look like with parentheses. And again, it will work without parentheses as well. Later on, when we learn about adding more calls, such as a count call and a distinct call together, some sort of parentheses structure will actually be necessary to clarify what is actually being called on what. But we're going to see that in a future lecture. Let's first think about what does it actually mean to call distinct on a column. Imagine a table of people who were surveyed to choose a color. So here we have the names of the person, just their first name, and then the color choice they made. Let's imagine we actually called select distinct from the name column from the color table. We'll notice that we have two instances of David inside this name column, which means when we actually select the distinct names from this table, it's going to return back the following, just the unique first names in this actual column. Keep in mind that given the previous example, we don't really know if the person of the name David was a duplicate entry who happened to change their color choice later on as the same person, or if it was two different people that happened to have the same first name. Calling distinct on this particular column just answer the question, what are the unique first names that are there in that table or in that column? It probably makes more sense to ask how many types of unique color choices were there. So what we can do is say select distinct choice from the color table, and here we have all the distinct or unique color options that were chosen. Let's go ahead and see a couple more cases of when distinct would be useful. We're going to jump over to pgadmin. Alright, here I am at the query editor. What I'm going to do is first explore the film table, and there's different ways I can do this. Since this is a pretty small database, I could either expand on this film table to see what columns are available, film ID, I could scroll over here, title, description, or I could just say the following, select everything from film. And it's okay to do this since this is basically kind of a toy database and toy table. It's not going to be huge. So we'll go ahead and just run that. And we can see here we have the film ID, the title, description, release year, language ID, and I can keep scrolling to see other information and other columns that are available inside of this film table. So let's think about what kind of questions distinct can help answer. Distinct really helps when we want to know the unique values inside of a column. And if we take a look at these actual tables here, something we may want to know are how many different release years do we have inside of this film database. And what we can do here is say select distinct, and I'll put it in all caps since we're treating it as a SQL keyword. You can see it's highlighted as such. And then we'll call it on release underscore year from film. So if I run this, what's happening here is it's going to return back just 2006. So this quickly answers the question, how many unique release years do we have inside this film table? And it ends up we just have one. All of these films were released in 2006. If we take a look back at this, I should also note that we can add in parentheses. And we can see here that it's directly connected to distinct. And if we run this, we'll get back the exact same result. And for some people, this is more legible, coming back to their old SQL queries. It works either way, so it's really up to you if you want to use parentheses or not. Let's come back and take a look at the entire table again, just so we can check out the columns. You'll notice here we have the release year. Something else that's interesting are the rental rates. And it does look like we had different numeric rental rates. So some movies rent for $4.99, some rent for 99 cents, others rent for $2.99. Distinct can help us answer the question, how many unique rental rates do we have? What we can do then is just say select distinct, and with or without parentheses, we can say on rental rate. We'll go ahead and run this. And here we can see that we have three distinct rental rates, essentially a low tier at 99 cents, $2.99, and $4.99. Later on, we'll be learning how to actually sort these or order them based off a certain value. But right now, PostgreSQL just returns back information as efficiently as possible. So you may actually get these in a different order depending on your operating system. Alright, that's it for the lecture on Select Distinct. Coming up next, we're going to quickly test your new skills by giving you a quick little challenge on Select Distinct. I'll see you there.